Hello, this is János, it's Reverb Audio, and today we are going to have a capacitor extravaganza episode. So we had lots of discussions with Nick about capacitors, so now I'm going to streamline it a little bit and just focus my thoughts, and Nick is helping me with focusing. So let's just switch to my Buy Me a Coffee page, and then Nick was super kind that he just posted it there, and thank you, Nick. That so I think this will help really all of us to go through in my recommendations. So may I ask about your aversion to Nichicon and Rubicon caps? What is that about? Rubicon made black gate caps, which you know are extremely desirable. I believe Rubicon is also the OEM for audio note caps. And I think what I know of audio note is that the chemistry for black gates is different from what they use for their other Rubicon labeled lines. So the black gates were quite special, quite different, and I heard really good things about black gates, but I myself never tried them. Actually, I have about a dozen of pulled black gate caps. I told Nick about this story, but I think that's worth another episode in itself. It's quite long-winded, but it's also something that probably everyone who is DIYing and has electrolytic caps should know about that, if they don't know yet, because it involves a trick on how to keep your electrolytic capacitors healthy, which are just in your drawer. Because if you have a stash of electrolytic capacitors and you don't take care of them, within 10-20 years they will be ruined, and you can just toss them out. But there's a little trick that can keep your capacitors alive and healthy, and now I'm preaching about that, but the only caps I'm doing that keeping them alive and healthy trick is my black gate pulls. And why? It's a long story. Nick already knows it, but you don't know it yet. So anyway, so the other part of Nick's question is why I do have such extreme aversion to Nichicon caps, even Rubicon, and it's very easy. So eventually, whenever I use electrolytics for a long time, for like over 10 years, I used to use Nichicons because, you know, they are cheap. Why not? Especially here in the United States, it's really easy to get them. They don't cost anything, really, just a few pennies, and that's it. And and of course, as I was, you know, progressing, so now just this is just for Nick. This used to be the board, well, not circuit board, my chassis for my 6AQ5 amp, which is like a 6005 tube. That was the power tube, the same tube that the audio note push-pull amp uses. I forgot what the name of that is, which is their Auto. The Auto uses those tubes, but they use them in a push-pull config, and I think they use like 4 per channel. And what I did is I did a similar thing, but single-ended and 1 tube per channel. So this was like a flip power amplifier, about 1.5 watts per channel output. So same as my double Darling. So when you put 2 Darling tubes, that has the same output about as a single 6AQ5 or 6005. 6005 is the US military version of the 6AQ5. So 6AQ5 was what they produced for commercial use, and 6005 that they used for military applications. So exact same tube, interchangeable. 6005s are better. They have better tolerances, lower noise, endures a lot greater shock. So part of it is that they were part of, I think, this tube was part of the ballistic missile targeting system. So this power tube, the 6005, was designed to sit at the tip of a rocket coming at another airplane or towards a target, and that despite the fact that there's like explosions around it, which cause it super heavy G shocks, and the thing accelerating like crazy, and despite these extreme conditions, this vacuum tube is still operational. So I don't know about the 6005, but there's the British military version, the CV5311, that's even more extreme than the 6005. I think that we can withstand 60 G, 50 or 60 G shock during operation. Not that it doesn't break at 60 G, no, that it can. I think this tube works up to like a several megahertz range, or maybe tens of megahertz of range. And in that high megahertz range, it still doesn't skip a beat during operation when it gets a 50 G jolt. Imagine that. So that's how bloody over-engineered this tube is. So compared to that, the 6AQ5 has the same parameters, electrically the same, but it cannot withstand 60 G. Maybe it can withstand 5. I don't know. I never measured it. Anyway, so that's the really long story of the 6005, and when you hear like an auto amplifier with these tubes, that's part of why it sounds so bloody good, for despite being such an easy and cheap tube, because it was built with the same brutal specifications in mind as a 300B. So the 300B was also built to be like an extreme military workhorse. That one was built to different specifications, but it was the same way brutally over-engineered as the 6005. So, long story. So this was my little board. So this is a piece of aluminum, and I did not use a full aluminum chassis. The rest of it was wood, and only this bit that housed the tube sockets did I make it from a metal. So most of the chassis was wooden, and just a little tip is that the less metal you have in a chassis, the better it sounds. Why? Because there's less added capacitance. Of course, you need to know what the hell you are doing, because there's no metal cage that provides shielding from other electrical fields and EMF and annoyance. So maybe if you live in like next to a radio tower, that might not work for you. But if you are a little bit fortunate, like you don't live next to a broadcast station or like middle of an industrial zone, but in a regular home, like 99.999% of us, then the more wood and less metal you have in your chassis, the more organic the sound will be, because there will be less capacitive interaction and less, you hear that? Metallic resonance. When you play music, any kind of mechanical vibration will add that nasty metallic tinge aftertaste to the sound. And if you don't have that, wood doesn't add that sort of sharpness to the tonality of the production. So anyway, this used to be part of my amp. I called it the Cricket, and it was a 6AQ5 or 6005 power amp, single-ended, and I run it in triode mode. Now I'm just having a look at it. So if you look at it, this is how it was. Now it focused on it. Maybe I can use a screwdriver. So these were up here. They were the power tubes up there, and here these were the driver tubes. And guess what? For the driver tubes, I used the 6J4 or 8532. That's the military version, 8532. 6J4 is the, did I say 6J5? It's 6J4, not 5, 4. Different tube, very different tube. J series, but different tube. So 6J4. and there the military version 8532, and I just urge everyone to go for the 8532, a lot better. And same thing for the power tubes, use the 6005 and not the 6AQ5. Of course either will be fine, but you will see an upgrade if you go for the military versions. It's kind of like you can feel you are stepping up, especially if you go with the driver tube update and power tube update. So what does this have to do with Nichicon? Right, you might be wondering, János, this is all really exciting. You're talking about the flip power amp, but the question was about capacitors. And my reason is that this was my first amp where I started using Nichicon for cathode bypass for the driver tube. So bingo, here we are, right? And it's still there. I can show it. There's my little baby Nichicon there. That's for the cathode bypass for the driver tube. And I was happy with its sound. So basically, when you see it, again, so driver tube, and that's a Russian oil cap, and that was feeding the power tube, and it was running triode mode. And as you see there, maybe on this side here, you can see better those are Zeners, two 6-volt Zeners, and the screen was connected to the plate with two Zeners. So and even though a Zener diode is a diode, but when you apply it in that position, it paradoxically makes the music sound more musical and more organic. It's just kind of interesting. So when you have a Zener diode in that position, what it does is that it makes sure that the voltage of the screen stays below the plate voltage, because that's what you want. For many tubes, if you have the screen voltage higher than the plate, it means that more electrons want to run through the screen grid than through the plate. However, the screen grids are tiny, flimsy, little tiny thin wires compared to the massive plate. So if the screen is at a higher voltage than the plate, then it means that that screen will be massively overloaded, stressed. There are some certain tubes that are designed like that. So for example, ER34 can take that, or like 6550 can take that, but even those, for any tube, if you play around like a KT88 or KT66, just try keeping the screen at a lower voltage than the plate, and you will hear it immediately that the presentation becomes more organic. Yes, you will have less apparent power than like using it so that the screen can swing higher than the plate. Then that will result in like more muscle, more beef, with a speaker that is not as revealing. But when you have a more revealing speaker, then you will hear that it's not simply more beef, but it's distorted beef. So it's kind of like not the prime cut of the beef, but maybe like a week old, somewhere from, it's from a bin, that was put aside for, like we use that for dog food. So anyway, Zener diotic. If you don't know, use the Zeners to convert a pentode or a tetrode to run into triode mode. That's the best trick. And don't just connect them together to connect the screen and the pentode, because then the screen can still be stressed out. The normal trick is to put like 100 ohm resistor, so the screen is protected a little bit. But the Zener works better than 100 ohm resistor. It sounds, the harmonic richness, naturalness of the sound is better than with a plain resistor. Because somehow with the resistor it also limits the current, that the more the screen draws, the more the resistor starts to cut, so it acts like as a negative feedback device, while the Zener, it's just keeping the constant voltage regardless of the current. So basically it just makes sure that there's a set amount of voltage differential between screen and plate, and then whatever current the screen wants to draw, it will draw fine. So that's a little trick. So what's up with Nichicon? And so when I had this amp, I was really happy with this circuit as it was, and why I was so happy with it? For several reasons. One of the reasons was that this amp was not like a super resolving amp, and the prime benefit of this amp that it was really dynamic sounding. It was super dynamic, and these Russian oil caps, they have a very smooth, very good sound. So if you want to play around with oil caps, like get into the zone of making the sound more organic and less audiophile, this is like a really cheap trick to get there. Well, I got these like 20 years ago, then they used to be really cheap. Now I don't know what's the price of Russian oil caps. Back then I bought a bunch, and then I haven't bought any since. So maybe prices have gone up, I don't know. But sometimes, I'm saying this because sometimes like some audio component prices just skyrocket, and you think you got them like really cheap 20 years ago, they might be at the price of gold today. I don't know, I hope not. Because that's, if available, that's like a really cheap entry ticket. What their limitation is their body. Their metallic bodies, I think it's magnetic. I'm trying out. Yes, you see the magnet, it just sticks there. You see it's taking off, oh, the cap. It's really magnetic. They have this iron body that where the capacitor is housed, and that added magnetism that smears the signal a little bit. So if you already have like Ori cap or something like that, some more refined plastic capacitors, then this will be a big step back in transparency and detail level. But in any way, they have really nice tone, and because of that magnetic smear that they add, what the Nichicons do was not that obvious. And anyway, the prime benefit of this amp was not that it was super detailed, but it was really dynamic. So despite the fact that it was 1.52 watts per channel, I had a really beefy power transformer with it, and so basically it had like a huge power supply that fed it gobs of power, and I was running my Zenith open baffles with it, like the 12-inch Alnico drivers, and guys, what I can say is that little unassuming amplifier with the Zenith open baffles produced the very best Led Zeppelin I ever heard in my life. Goodness, and King Crimson, freaking amazing. And back at that time, Mitzi, my cat, was still alive, and she had two favorites. One, Bach, and the second, Led Zeppelin. And if I put on Led Zeppelin, she would position herself in the best listening position, where, so whenever I went next to her and I put my ears where hers is, it sounded the best where she was sitting. So she was, I called her an audiophile watch cat. And every and any time she could pick a position, and when I saw that she's listening to it, you could bet on it that was the best seat in the house that she picked. So why is it that she picked different seats? Well, it's because over time, over the years, I had different furniture in the house, or when you bring in something, or even if you move your sofa a bit, or one chair like a couple of feet from the side, it will change the optimal position of the sweet spot if you move your furniture around or you put big objects in the room. Yes, or even if you have like temperature fluctuations because of temperature changes, the nodes, the acoustic nodes, where how your room behaves changes, because with the temperature and humidity, the actually with the temperature and the pressure, the air pressure, the length of the sound waves change. So but your room length stays constant. So while you maybe have one day a room node for 40.0 hertz, a couple hours later or next day it might be 40.2 hertz, the node for that. So that means that like a couple of centimeters are affected by the sound, or even more than that. And so Mitzi, the audiophile watch cat, she was the best listener, and she always, like, if I put on Led Zeppelin, she immediately, as soon as, you know, the needle hit the groove, she whoop, and then she was like, kind of, you could see on her that she is like traveling a million miles away. So she could confirm that I was not imagining things. She really could. Oh my God, best ever Led Zeppelin. And you might say, oh, János, isn't the voice of Lancelot better? Guys, very important thing, and girls, it is not that we are going through like this and this, and oh, it's getting better and better and better, more transparency, more dynamics, whatnot. And yes, I think if I paid Led Zeppelin now, it will be more impressive, a lot more impressive than what this little baby did with my primitive Zenith open baffles. But that acceleration and that boom, how it did, is just, that's one of my listening experiences that just kind of like, you have a few of those in your life which you really remember and make a big impact on you. And this little amp did that with Led Zeppelin and King Crimson. But like classical music, my darling amp was better, much better suitable than this circuitry. And my darling amp it brings me back to the Rubicon, because I put there Rubicon for the same position that I here have the Nichicon. And there I use the same tube, because this is the driver tube for the darling amp, the 6J4/8532/CV5311. And before, guys, I made a huge mistake when I said 6005. I mixed that up with the 5311. So the 5311, that's the high impact tube. That's in the rockets. That's the 5060G tube. The 6005, that's not rated to 60G. And the 5311, it's not the premium 6005, it's the premium 8532. So that's the driver tube. The power tube 6005, that's pretty much the best there is. So it's just 6J4 6005, and for the driver it's 6. Okay, I think now I'm really phasing out. Let me just write these things down, or I'm just going to point them. Driver tube, a pedestrian version 6J4, military version US 8532. That's already in the rockets. 6J4 TV and stuff, radios, audio and TV. And the British military, that's the CV5311. And these military versions both are the high impact, extremely rugged like crazy, and these work like super high megahertz range, and they are frame grid tubes, so they're just brutally over engineered tubes. And now for the power tube, that's the 6AQ5, and the military version is the 6005. And the 6005 is the half power version of the 6BQ5. I think now a lot of lights are switching on, like, ooh, 6BQ5, we heard a lot about that. Like the Dynaco Stereo 35 that uses the 6BQ5, and that's like the half power version of the EL34, and now all the lights are on, right? Everyone knows EL34, how nice sounding they are, but little is known that the 6BQ5 has 10 times better tone than the EL34. I think it's a 10 times better tube. Why it's not so popular? That's because EL34 has twice as much power, and in our audio history we are going towards more and more power hungry speakers, so we need more watts to drive, so everyone wants like multiple EL34s in their amplifier, so the 6BQ5 was not in the attention span of people. So you typically what they have been using it was like for a driver tube for a 300B amp, for example, in that role, which is amazing for that. So if you want a nice driver tube for 300B, 6BQ5, awesome. Now, what really few people know is that the 6AQ5, more precisely the 6005, has even better tone than the 6BQ5, but now we are going to the sub 2 watt category, so you need like really efficient speakers. So that's why people are not using it typically, because you need like close to 100 dB efficient or sensitive loudspeakers to be able to enjoy this power tube in single-handed mode. And that's why Audio Note in the auto is like doing this parallel push-pull application to get enough power to use for a normal loudspeaker. So basically, here I'm using these driver tubes with the Nichicons, and in my Darling amp, I use them with Rubicon as cathode bypass cap. So like it was a step up, and definitively I could hear that that amp is a little bit more nuanced than this Cricket was, and even though that had different power tube, that also added different power supply, lots of additional differences, but I could tell like the noise floor of that amp was a little lower because of the Rubicon cap partially contributed to that. And I have changed a lot of things in my system with the Darling amp. It morphed into the present day KT66 amp with a very different driver tube, but that's the same chassis and which went through the same amp that went through like hundreds of reworking, hundreds of iteration until I reached where it is now. However, during the first 10 years or more than 15 years, I never touched the Rubicons because I just thought of them, you know, everyone has such high opinion of Rubicons, they must be really good. It didn't even occur to my mind to play around with them. I changed pretty much everything in that amp, but the Rubicons were there. And it was here already in this house. Then one night, I just decided, okay, I got a couple of Elnas Silmic 2s, and I changed the Rubicons for the Elnas. And I didn't expect, because like from what I heard online, some people prefer Elna, others prefer Rubicon, and did not expect that much difference. And when I swapped it, I had a holy shit moment. And at that time, I really wanted to build a bonfire and burn all the Rubicons on that bonfire, because the difference between Rubicon and the Elna was just so striking that, oh my god. So when I put in the Elnas, it was like noise floor disappeared. Before that, I thought I have no noise floor in my system. But when I dropped in the Elnas, that was like, holy shit. Now it's like, that's when I didn't hear noise with the Nichicon, and with the Elna neither, but I could finally hear the micro level dynamics. just such low-level acoustic information started to come through, which was just truly mind-blowing. That was not there with the Rubicons, because that it produced the haze over that super fine detail level, and that was just like a truly mind-blowing experience. And it wasn't just that added the microdynamic capacity, which, by the way, I think that I can that was so striking, because I was using the voice of Lancelot with my big Altec speakers with it that have like 102 dB, roughly that's the efficiency, and per watt meter, not that 2-volt nonsense watt meter. It's much higher in watt meter than in that 2-volt nonsense would predict. So with these, they have the ability to reproduce that really low dynamic range material. If I would shift to the Mirage, probably I would not notice that. So you need a dynamic loudspeaker to enjoy that super low scale production. But also what it did is that it cleaned up the soundstage a lot. And not in a way to make everything like a pinpoint type, but it's kind of like a fog that disappears from the room. With the Nichicon, it feels like kind of like when you are listening to a jazz concert in a pub and everyone is smoking, and you get the impression that the smoke is just veiling the performers, and you cannot see them, but you can't hear them as clearly either. So that was kind of the analogous impression that I had from changing the Rubicons to the Elnas. And so yeah, and Elnas are more expensive than the Rubicon, but it was kind of like a $1.50 versus 30 cents. And come on, there's like $1 price, the cheapest trick for huge gains. It's kind of like I'm at a level where I would need to throw like $10,000 value stuff to make a noticeable change, and that tiny thing like a $1 change that brought with itself like a giant explosion, so the value of that was just like immensely magnified. So that's why my aversion to Rubicon and Nichicon, and eventually with Nichicon, I used to use Nichicon in my power supply as well, and that's what Nick asked too. And here I have to hit the pause a little bit, but it will be for myself. For you, I will continue to record this video. It will be just in a second. I'm back. I needed to recharge. So back to power supply capacitors. So I used to use Nichicons in the power supply as well, because power supply caps are expensive and Nichicon caps are cheap. So that's what you use when you start experimenting. And then of course you can step up from there. So with the Cricket amp, I had big Nichicons in the power supply, 330 microfarad. I think like it was like a CRCRC filtering, and I just did it with brute force. Just wanted to keep it cheap and simple. So my concept for this amplifier was just, how can I build like a simple and cheap amplifier that sounds good? And it sounded pretty good, surprisingly good. Of course I was using it on my void pipes, which is like 96 dB efficient, so I had no problem with that. And however, what about other power supply caps? So that's what Nick is asking about. What do I recommend for power supplies? So back then, what I did, the cheap choice was Nichicon for power supply, and for my darling amp I used Sprague Atoms, and those were a lot better. But now you cannot get Atoms anymore. They stopped making them like 20 plus years ago. And why the Atoms were special is because they were designed to withstand very high surge voltages. So if you had atoms like which were 400 volt rated, or any kind of voltage rating, they were designed to withstand a very brief surge of up to twice the rated voltage. So basically, I had 500 volt rated Sprague atoms, so they can withstand a few second surge of a kilovolt. Now, those of you who know about electrolytic capacitors, you know that when you get like a Nichicon that's 500 volt rated, if you give it like 510 volts, it might go up in a smoke. They are designed that when you read a voltage rating on the Nichicon, that's the absolute worst case scenario. So if your circuit, let's say, calls for 480 volts, and if you put in a 500 volt rated Nichicon, that's not sufficient. Why? In normal operation might be okay, but if you turn on, there's a surge that's going to destroy your capacitor, or at least how that destruction will occur is that its expected lifespan will shrink, and you will need to change that capacitor much sooner than you expect to change capacitors in an amplifier. And also there's a high risk of that capacitor failing during operation when there's like a power fluctuation in the mains voltage. For example, if there's a power outage and the voltage comes back, that cap can fail very spectacularly on the spot. And so that's why if you get a Nichicon, I would say like at least 25% or more over voltage from what you think it will be running. Just keep it more, and even then it will be stressed, and they really sound as if they have a stress on them. So for Nichicons, either as cathode bypass or power supply capacitor, they sound as if they were lowering capacitance in a power supply position than what they are. So if you put in like Sprague atoms with the same capacitance, they have a lot more bigger body than the same capacitance Nichicon. So like if you double the capacitance in Nichicon, then it will sound like an equivalent Sprague atom. And also they have like a really loud noise, that electrolytic hiss that it has, which is just veiling up the sound, destroying dynamics, and mucking up the sound stage. And in power supplies, it's just kind of like anemic sound, and kind of like a transistor radio, like cheap transistor radio in the wrong kind of sense. There are really good transistor radios too. But I'm not thinking about a really good I'm thinking of the stereotypical transistor radio sound that they give to your audio gear. So after they stopped making the Sprague atoms, then even though my mentors too he had I think like about 20 kilograms worth of Sprague atoms. That's what was his stash. But by year 2010, they were dead. So we tossed out with him, I think, like at least like 50 pounds weight of Sprague atoms to the dump, because they were dead. Because if you don't use an electrolytic capacitor, the electrolytic layer, it degrades over time. And if it was made like 20 years ago, 25 years ago, no voltage on the capacitor, it will be dead. It's just dead weight. Yeah, so that's kind of a sad thing. So after my mentor passed away, and we were cleaning out his store, I think I took to the landfill maybe like 400 pounds in weight of electrolytic capacitors that were dead. Yeah, so yeah. Anyway, so make sure that if you have electrolytic capacitors that you cherish, that you have it in your storage, put a battery, like a 9-volt battery on it, to keep them alive. How and what, that will be a part of a new video. I think I made a video on this many years ago, but probably that's not in the title of the video. It's hidden somewhere in my videos, and it will be easier to share it with you, to make a new video on it than anyone trying to find it. It's hopeless. You just find it by chance. So anyway, back to Sprague atoms. So after the Sprague atoms were done, were toast, I could not try them anymore. Actually, that's how we found out that they are toast, that I told Stu, can I have some more Sprague atoms? Because I think I want to like change the ones in my amp, just to make sure, you know, I've been using that amp for like 10 years and maybe let's switch it to fresh capacitors, and then found out they're all dead. So I had to go on a quest to find affordable high quality capacitors. Of course I couldn't afford Blackgates, so that's why I wanted to find something. And that's when Kyle told me, Kyle Kuroda, he's also one of my audio mentors. He was the one who guided us through the Darlingen build project. And Kyle told me, oh, I heard somewhere that there's this capacitor. On one of the audio forums it was mentioned that this new technology is coming out called the DC link film capacitor technology. And they invented those for inverters, for solar panels, and maybe you want to try it out. And he got like, I think, Panasonic brand DC link caps, and he shared some with me. And I tried it in the power supply in the Darling amp, and I went like, holy crap, this is freaking amazing. So since then I started using DC link caps in the power supplies, and DC link caps are similar to Sprague atoms in a way that they're also designed with the double over voltage criteria. So basically, if you have a let me just grab. Here's a DC link cap. I'm just grabbing one from my desk. So this tiny thing, this is a 10 microfarad DC link cap. This is a CAMAT. It says MKP-C4AQ. So that's, if you want to look for it, C4AQ series CAMAT. That's Swedish film capacitor, 10 microfarad, 500 volt rated, and 105 degrees Celsius. So it's designed for really extreme, really hard operation, and also for inverters. They have like extreme amperage, so the capacitor is run very, very hard, and that's where like capacitors have a very big difference between them. Even like if you look within Nichicon, they have very different capacitors, and look for ones that can take very high ripple. So they specify the ripple current for the cap, and of course the bigger the capacitance, the bigger ripple it can take. But if you talk about the same capacitance, you can find capacitors that can take like 5 times the ripple than a general cap, and these DC link caps can handle enormous ripple, far beyond what electrolytics can handle without failure. And the thing about capacitor aging is that the higher the ripple for the cap, the shorter the life, because it's stressed more. And when you have a power supply, the first cap in the power supply, that takes the biggest ripple, that has to smooth out like the mother load of ripple. And that capacitor is the one that will go the first. So for example, if you are on a really tight budget, and let's say it's like a 420 volt is your operating voltage, and you are buying 450 volts rated electrolytics to take care, my recommendation is that like the C2, C3, like downstream, you get by with those, but the first cap, put there something that's 500 volts rated, that's higher rated, because that will take a beating, and if it's barely in tolerance, that will fail. By the way, that's why cheap tube amplifiers have such a bad reputation and made the reputation of tube amps so bad, because the tendency was to really get the lowest possible rating capacitors in the power supply, and of course they fail. Of course, you can't cut corners there, especially with the first capacitor. But companies are making it because for them, like their cost margin is just like they have to present the package like as at such a lowest possible price they can. Otherwise, the customer, you know, if it was like 20% more expensive than what it is, then they would lose to the concurrent company. They wouldn't make it. So, however, if you're a DIYer, you can afford for yourself to put like a couple dollars more expensive capacitor, which also means you need a bigger chassis. So that's why it snowballs, and yeah, it's just like putting there a better electrolytic capacitor might be like a $20–30 difference, but it's not just the dollars, it's also the space. So you have to make the chassis bigger, and then it snowballs. So what I started doing is started using these DC-link capacitors. So Kyle read specifically about the Panasonic, and I tried out Kemet. The Kemet just started making these as well, and I found that the Kemets are just as good or maybe even better than the Panasonics. And then ever since then, this was when, I think before, around 2010 or so, or maybe even sooner, 2006, I don't know, 5? Long time, really long time ago. So, and these ones, the good thing with them is that they are similarly rated as the Sprague atoms were. That's why I was really eager to put them in place of the atoms. That it says 500 volts, and it means it can take a kilovolt spike, but it's fine playing at a kilovolt. So the thing with these are even tougher than the Sprague atoms were. So if this is a 500 volt rated cap, and if I would put it into a system where it constantly is under 700 volt, it wouldn't break a sweat. So that's why these caps are just extremely brutal. And for these caps, what they do is they are self-healing. So when you have a high voltage, when it's doing damage in a capacitor, it means that there's capacitor layers, layer next to layer next to layer, and when there's a failure, it means that between two layers there's a short. There's so two layers are shorting to each other, and that's why over time, when you have more and more and more shorts, then you have less and less effective layers, and the less layers you have less capacitance, because you need the number of layers to build up the capacitance, and as during each mechanical short, each electrical short, not mechanical, electrical short creates those fusions, then you lose capacitance. With the electrolytic caps, it's really drastic, and the capacitance can drift quite a bit, like 5% or even more. But with these guys, what the industry specifies for them is that the end of life is specified as a 1% drift from normal. That's because when there's like a punch through, then the layers self-heal. So the damage will be undone. When you drop down the voltage, it runs under normal operation. Then that point where where the two layers stuck together, they just get unstuck, and whatever was there, it heals. However, if you constantly batter that 500 volt cap with a kilovolt or kilovolt and a half spikes, then it will have areas where it permanently fuses. But even in that case, it will lose only 1% of the capacitance. So pretty much a cap that is considered as failed, it's still better than an electrolytic capacitor in its prime. And these have just brutal longevity. So the lifespan before you have 1% drift in capacitance, if you keep it at like, for example, this is 500 volt rated, if I use it at 450 volts, it will have about 1 million hours of operation before it loses 1%. That's just unbelievable, incredible, which is like, 1,000 times my lifespan or something like that, what I could listen to if I was listening that much. So basically the best thing with these capacitors is these are built to last, and the only way you need to change it if it corrodes, if you do something with it and the wire that goes into it corrodes, or you like punch it through with, maybe like shoot through it with a gun, I don't know, maybe that's the only way it will fail. Otherwise your whole amp can, rust or whatnot, and these capacitors, even your grandchildren can use these caps. So you forget about capacitor changes once you start using de-sealing caps. With normal caps, electrolytics, you have to keep on changing them, because the electrolytic layer, it breaks down if it's not used, or even if it's stressed, it still breaks down. So that's why when it's breaking down from over voltage, then it will start to produce gas, and that gassing, there's always, you see there's an eye, there's on the big electrolytic capacitors, there's an eyelet, and when it pops out, that means that that cap is really close to dying. You must immediately change that. So if you see that thing bulging on your big electrolytic capacitor, immediately change it, because you are just one power outage from that thing blowing up, literally blowing up. Or maybe 2 or 3, but anytime there's a power outage and the electricity coming back, that you got a serious chance that the thing will just spectacularly, like literally explode. And that's because due to the electrolytic breakdown, the gases are building up and pressurizing the capacitor. And it has like a metal can. So imagine a gas building up in a metal can, and then you put 500 volts in it, or 100 volts, or even if you have a solid state amp, 50 volts, but high enough capacitance, that thing will just boom, blow. And not a nice thing, spilling acid all over your internal parts. Not fun to clean up, not at all. Basically, like you can do any job cleaning it up, probably in 5 years, half of your circuitry will corrode anyway, because the acid just eating up everything. If you have circuit boards and the cap blows up, okay, sayonara to that circuit board. Not right away, but it won't last more than 10 years. Yeah, so back to where I was. So these de-sealing caps, why do I like them? They have like negligible series resistance, and they have the biggest ripple current capacity you can imagine. So it means that they have like really unlocked dynamics. These are dynamic as F. I wanted to say something with F that doesn't sound like that four-letter word. Anyway, that sounds like crazy dynamic. And so that these de-sealings are, first of all, film capacitors. So they will give you like a similar level of details, transparency, dynamic range, frequency handling as like a dedicated like audiophile cap, like an Ori cap or a Clarity cap would provide at fraction of a price. These are like nothing. They cost like an electrolytic capacitor, just incredible. And I used to post about this on forums, but didn't catch on. People just continue using electrolytics, fine. There's like a few guys who started catch on. There's like, I think Alek Kitic, he started like using these as well. Around the same time as I did, and I think I've been posting about these things like for half a year, and then I heard the feedback that he started using these. Maybe he started earlier too. I don't know if it was my influence or not, but you know, these Eastern Europeans, right? He's Serbian and I'm Hungarian. Just like, you know, these guys are just, you know, are a little bit more astute about the developments and what we can do, you know, value products in audio. So we come from a background where you are a lot more concerned about being value cautious when you grow up in an environment that that does not allow for you know, unlimited spending opportunities, because there's nothing to spend from when your pockets are relatively pretty empty. Anyway, but that doesn't stop anyone from, you know, getting into things and finding out uncharted areas, and these de-sealing caps are just bloody amazing. And I noticed I tried like bypassing them with oil caps or Russian oil caps or obligato or something, but you don't need any bypassing. And I also use them as cathode bypass caps, because you can put like a 40 microfarad or 20 or even 10 depending on the cathode resistor, and they are really good. Also, speaker crossover, I use these in the crossover, and I have a dual wound cast. I'm ashamed to admit that I have a dual wound there. Parts Connection had like a 75% off, and then I bought 4 dual wounds, and then I put them over these, and with that bypass, it sounds as if the whole thing was dual wound. It's that good. So I have these are like 0.47 microfarad dual wound casts over 40 microfarads of de-sealing, and that's like a 1 to 100 range. And I think yes, that was Nick was asking about, like a 0.45 film on a 47 microfarad electrolytic. Yeah, so that's also the ratio that I've been always using, the 100x, because it's usually that top one. So like if you have like, let's say, 100 microfarad capacitor, then it is really good at lower frequencies, at charging, discharging, charging, discharging at lower frequencies. And then you go for a smaller capacitor, it's much better at charging, discharging at higher frequencies, but it sucks at the lower frequencies because it doesn't have enough capacitance. So that's why you want a big capacitor that can take care of the lower end of the brunt of the current, but you want the top 1% because that is the range where that big capacitor is already compromised. So when you put 100 times smaller cap, it operates in that range where that's the optimal range for the capacitor. So while the big one is charging with that let's say with that 20 hertz note, then the top 1% is able to produce that the kilohertz or 10 kilohertz charge discharge pulses that is required when you have like a symphonic music and boom, someone has like a timpani beat and someone is playing a piccolo next to it. So if you don't have the tiny bypass, then it will be boom, it will be just that big boom, and the piccolo will be mushed, like kind of like smeared. But when you add that 1% bypassing, because it can charge discharge, it can also supply those fine fluctuations, which the big capacitor cannot really, because it's so big and it's just charging up with that woo big incoming inrush at low frequencies. So now with films, the films are made in a much better way, and this issue is not as much. So I noticed that you don't really need to bypass them. In the crossover I did, because there it is sensitive enough that if you put a very high quality film cap on top of these film caps, it will be an improvement, and these synergize extremely well with both obligatos or miflexes or dual wounds. Dual wound is coming from the Miflex factory. Sadly, the Miflex, which is the Polish OEM manufacturer for dual wound, sadly they closed down. I don't know if dual wound is still using them as the source or what happened. I'm not familiar what's going. I just know that you cannot buy Miflex capacitors anymore, sadly, which are my choice of film capacitors. I think the finest you can get at reasonable prices. Not anymore, but those synergize extremely well with these. And by the way, when after these break in, these sound almost exactly like Mundorf Evo oil capacitors. It's just very, very similar. So if you have like a Mundorf Evo oil on one side, and you have this on the other side, other channel in the crossovers, you won't notice that you have different caps on left and right speakers crossovers. So that close in tonality to each other. And yeah. So that's my thing about these capacitors. One note for everyone: if you are working with these, when you work with them, be really careful with that, because they have like really low ESR, really low series resistance. What it means, they can discharge a lot faster. So in my lifetime, from my audio adventures, like working on amplifiers, I got jolted by charges, by capacitors, and in the amplifier and working, or just like turned off many times. And I can tell that the electroshock from these caps is a completely different league from the electrolytic capacitors. I would rather get shocked by 500 volts from an electrolytic cap. I would rather discharge a 500 volt Nichicon like this than a 300 volt DC link of the same capacitance. There's that huge, humongous difference between them. It's just like, oh my God. So these just don't have electric mishaps with these. That's my advice to anyone, and all of those us who have been working with capacitors lifelong, is that when you zap yourself with these, that's in an entirely new league. And what that hints at also is that they can discharge a lot faster than a normal capacitor, which means much bigger dynamics, because if it can release electricity at a much higher speed rate, that translates into better dynamics. Yeah, so that's why I use now exclusively these caps in the power supplies. And also because of that, you have to be a lot more careful about the power supplies, because you are supercharging them, and everything else in the power supply will be extremely transparent and apparent. Also, you have to be careful to use a smaller one as your first capacitor if it's a tube rectified supply, because it's going to drain the charge much faster from the rectifier. So if you put in like a 20 microfarad electrolytic as a C1 after a 5AR4, let's say like a Softec 5AR4, that tube will be fine. And put in a 20 microfarad DC link, probably in 2 weeks that rectifier will die, because it just cannot handle the fast charge of the cap. So whatever electrolytic cap you have in a tube rectified amp, just put like a quarter the size in DC link cap to keep the same safety as the manufacturer wants to have. And of course, with that, what it means often is that tube rectifiers, when the C1 is really critical for noise, especially for single-ended amps. And what I do with any commercial amplifier is that I don't change the C1, the first cap. I add an additional DC link, like just a small one, a 5 to 10 microfarad first cap, and then put like a 50 ohm resistor, 47 ohm resistor, 5 watt rated wire wound resistor, and then even though, like for example, for quicksilvers, which have like really massive capacitances, like 330 microfarad rated and 550 volt rated 330 microfarad, that's pretty typical for quicksilvers. I put in like a 10 microfarad film cap, 45 ohm resistor, and then you would say, "Ooh, you put resistance, it slows down the power supply." Heck no, it will be like 10 times more dynamic, and it is just like it's like a wow moment when you do that. And that's also because it will just like an extra step of smoothing. What it does, it also, because now we have a much smaller, like a 10 microfarad instead of a 300. So even that, though that 10 draws like as much as like a 20 or 40 would, but it's still like 40 versus 300, that 10 times less demand on the power transformer. So what happens is that the higher your first capacitance is in a tube power supply, it means that the time for each cycle when the capacitor charges will be shorter and shorter. So what you will see is that the phase where current is available and where voltage is available will just not be the same. They will just be more separated with the bigger your capacitor is. And that's why choke input supplies are more superior, because there you don't have this limitation as the cap input supplies have, that the bigger the capacitance, the shorter the charge time, and when the charge time is really short, it means that it also drains that charge from the power transformer in a fraction of the time than a smaller capacitor would, because it still gets the same amount of energy as demanded by your system. But because it's doing it at a fraction of the time, it will make your power transformer ring. Like each current draw is like a wing, wing, wing. So it's kind of like ringing a bell, dang, dang, dang. And when you put on this is like 30 times smaller, like a 10 microfarad versus 300. So it's like a 30 times smaller gong at the power transformer. And what you can see is that when you have like lower quality power transformers in many amps, that it shows up as that the transformer is buzzing. Bzzz. And that's why it's buzzing, because there's that humongous first capacitance is just drawing way too much current. And you can fix that, put in an extra stage with a smaller capacitor, and that won't overstress the power transformer, because it will be still drawing the same amount of total power, but through a longer time of its operation cycle. And it won't be drawn at just a tiny sliver, so not during just like a 3 millisecond time, but maybe like a 30 millisecond time of that sine wave. So what did I want to say more about that? So basically just take care of that. And one more thing, why Quicksilver is doing that. I think now bells will be ringing in people's minds like, János, you just said like most manufacturers specify like 20 or 40 microfarads tops for a capacitor input supply for rectifier tubes. And nowadays, like even the Softec tubes, like if you have like even like 40 microfarad, it won't live longer than a year. That's pretty much on the dot. It craps out because it's stressed to hell. And the only thing you can do is put a much smaller capacitor, maybe 2-3 microfarad input, and then it will live longer, but then that's inadequate for anything. So there is always a compromise there. However, but what you don't know, what Mike Sanders figured out, is that US, NOS, 5AR4s, the GEs and the RCAs, oh man, they can handle 300 microfarad input capacitance, which is like 10 times the rated capacitance. And I had like Allen's Quicksilver amp, and that was like 20 plus year old, and he was on his original 5AR4 rectifiers. And he used the amp every day. So that's how well the US NOS 5AR4s were over-engineered. And then if you try to like put in a soft tag into those Quicksilvers, then probably within a week they probably explode, not just quietly fail, but literally explode from the extreme current draw. So that's one of the reasons why I was not a big fan of modern tube technology, because I started using modern manufactured tubes when the companies started producing them and marketing them in year 2000 and after that, and then the quality and lifespan was atrocious and the sound was atrocious. And today, what I hear from people, the sound improved a lot, but the longevity did not, and you just have to be really careful to use them. Really study the specifications of the manufacturer, because it might be the same name, like 5AR4 or maybe ER34, but check the ratings of the manufacturers, because it might be much less than what like a Mallard or RCA or GE or a Siemens had of the equivalent name tube. So that's another consideration that you don't hear often about vacuum tubes and how to use and pick. So let's see. So what next? I've tried Mundorf MCAP, MKP, and like their sonics in a phono pre I built. Yeah, actually I have not tried MKP. So this one I didn't try. I tried the Evo oil, and that. But usually Mundorf, what I hear from people, that they have like a kind of like a house sound, which is I would sign as the kind of like a more like a darker, balanced, really nice tonality sound, kind of like a lush grand piano, not like a squeaky Yamaha, but more like a Bösendorfer type of sound, and yeah, definitely in phonos I would use Mundorfs nowadays, that you cannot get obligato. So in my phonos I use the obligatos and miflexes, and I use obligato because it's kind of like a baby miflex, a cheaper version. It's like a ridiculously great value, very cheap oil cap. I hope we can still buy it. Sadly not miflex anymore, because that's yeah. So that's what my phonos have. And also my phonos, I'm using Kemet DC links for instead of the electrolytics for filtering. But some places, if there's no space, I think still in my violin I still have. I'm not sure what I have. I have to check. But there's not enough space for like a 40 microfarad film caps to put in there. So maybe I have to revise what on earth I have there, because I think I still might have some. Electrolytics, I think I put Panasonics there. Panasonic electrolytics bypassed by obligatos. I think that's what I have. Or maybe I bypassed with tiny DC links. You can also do that trick, like have like a, yeah, so maybe like try Panasonic electrolytic caps if you are really stressed for space, and bypass them with DC link on the budget. And or in size as well, because this is a 10 microfarad 500 volt cap. So like for no power supply you would need like a half a microfarad roughly. So that's like those are really tiny. Those are really tiny baby flat capacitors. They fit anywhere. So wherever you have like power supply, just use a Panasonic cap and put like a tiny baby DC link on it to really take away that top edge where they have that noise, which is not nearly as bad as with Nichicons. Nichicon is really unacceptable, and anyone who is affiliated with them. I heard that Rubicon is like also like kind of like an affiliate of Nichicon, or they were at one point, and that kind of mentality is that. So what I heard of this, I don't know if it's true or not, I'm not an insider, I just heard some insiders' views on this, is that Nichicon just gets all the US contracts, and that's why they just can afford to produce substandard components, because the state will order millions and hundreds of millions of parts from them anyway, and they don't have to be as strict as other companies like Panasonic or Elna or Kemet. They make a lot higher quality electrolytics. Oh, and even electrolytics. Kemet makes really good electrolytics, so you can use that as well as an electrolytic cap. I think maybe I have Kemets in my phono where I couldn't put these ceilings for space. Oh, where are we? I think now this one probably we are well over an hour, so I think maybe I will stop for here for now, and the rest about the resistors I think I will make a separate episode about that. So thank you, Nick, for your question, and thank you for sharing your experience. And by the way, guys who don't know, Nick is really a fantastic master of audio. He's a builder. He can repair audio gear and musician amplifiers, and he is a professional musician, and he's an audiophile, and he knows how to repair stuff at a very high level. So I think he is the most amazing audiophile alive today, because he has the all-around experience that we as audiophiles strive for, right? To have that education and the knowledge of an audiophile, to be able to tell things, to appreciate sound, also to have the ability to play the instruments, to produce the music that you are listening through your system, and then third, to build and modify your own gear and others' gear, and you know what you are doing. This is just absolutely fantastic. So now I'm on the way that sooner or later I want to turn myself into a musician as well. And I actually now, just yesterday and just now, like 5 minutes ago when I stopped between the two videos, I was chatting with a friend of mine that we are setting up regular sessions to drum together. So that's where, yep. So maybe that's one thing that I really wanted to do that for a long while, and now past couple of years I haven't done any of that. So that's really sad. That's sad. Anyway, so thank you, Nick, and thank you everyone for listening. I hope you had a great time with it. Bye bye. I'm looking for where to stop this thing. I found it.